the union of two probabilities. So that's basically this entire area divided by the area of the sample space. But notice here that this, so this is the event, A union B, it means something very specific. It is read, however, like so. So A union B, this thing, when you read it, you use the word or. And in English, or is ambiguous. What does or mean? I like to point out that while we'll be discussing or, we're not going to be talking about the definition of is. So what does or mean in English? Choice, okay. A little bit more precisely. If we say, like for instance, beer or wine, what do you typically mean?
Mutually exclusive, one
Right.
or the other.
Yes.
One or the other, but not both, right? What about if somebody says, let's see, similar situation. Appetizer or dessert?
Decent.
Yes.
I say both.
Right. So exactly, it's one or the other or both, right? So it wasn't a great example, but the idea is here is that if you're asking one or the other or both, you're dealing with an inclusive or. If you are dealing with one or the other but not both, you have something called an exclusive or. Fortunately, in statistics, at the very least, we're always consistent. We only deal with inclusive ors. So this is A or B or both. Okay, so in this case, we again list all the sample points where Markley is profitable. Well, no, where Markley is profitable but not Collins, where Collins is profitable but not Markley, and both. Assign the probabilities, add them up, and you get 82% probability for the event that Markley is profitable, or Collins, or both. Finally, well actually not finally, we have intersection. This would be the event that Markley and Collins are both profitable. And this thing, the upside down U, is read and. Okay, so just looking at this, which is going to be smaller, the probability of A and B, or the probability of A or B?
A and B.
A and B, yes. And in addition, well, just to illustrate it, we can count. These are the only two sample points where both companies are profitable. We have a 36% probability of that happening. But jumping the gun a little bit, if we have if this is A and that's B, and we want to find the probability of A or B, can we simply add the probability of A plus the probability of B? Is this true? No, why not?
Because there's overlap, double count.
Because they overlap, right. So how many times have we added this now?
Twice.
Twice, and therefore we need to subtract it
Subtract.
once. That is the additive rule, and it'll turn out to be quite useful. In fact, let's apply it. And you'll remember from before that the probability of A or B is 82%, but here we're calculating it the opposite way. 70% probability that Markley is profitable, plus a 48% probability that Collins is profitable, minus the joint probability of 36% gives you again 82%. These two are called marginal probabilities or unconditional probabilities. And finally, we get to the mutually exclusive events. And in this case, we have that if B happens, A can't happen. If A happens, B can't happen. So examples are male and pregnant. The next person walking through the door being male, the next person walking through the door being pregnant. You know one or the other, then if you know one, the other can't happen. Yes? Okay. One big problem in statistics is that people confuse this concept with independence. What does independence mean in English?
One doesn't affect the other.
Free? Yes.
One has no effect on the other.
One has no effect on the other, right? And quite often when I ask this question, I'm told two things are separate. And I think that's where the source of the confusion lies. So, for whatever reason, some people confuse this with independence. The problem is, in this situation, if B has happened, what do you know about A?
You won't.
Right. And if A happens, B won't. So clearly there is an impact between the two. These are not independent. If you have mutually exclusive events, they cannot be independent. And if you have independent events, they cannot be mutually exclusive.